In this video, we're going to look at the second half of class today for those of you who are missing class because of precautionary COVID isolations. And this is still dealing with the definition of subset, but it is looking at one of our new groups, one of the dihedral groups, and we're going to find a subgroup in it. So I want to recall that D4 is the set of symmetries of the square. And we have found that D4, under its composition, is indeed a group. It is a group with 8 elements, and it is a non-commutative group with 8 elements. And in a previous video, we even looked at the Klien table for D4. What I want to do now is I want to define a set that I am going to call K4, and K4 is going to consist of the do-nothing rotation, which I'm going to call E, the 180-degree rotation, the horizontal flip or reflection, and the vertical flip or reflection. And this set is usually referred to as the Klien 4 set, although it's going to turn out that it is a group. So this is usually referred to as the Klien 4 group. And I'm going to go ahead and ask the question as a question, even though I've given the answer away. I want to think about whether or not K4 under composition is a subgroup of D4 under composition. Now, they have the same operation, and so I kind of want to think about what's going on with what we need to be showing. So let's kind of start developing what this is. At this point, what this question basically means is K4 under composition a group? Because if it is, then we've got a subgroup relationship up here. So if this is yes, then K4 under composition will be a subgroup of D4 under composition. Now, to figure out whether or not this is a group, we have to think along these lines. We have to be thinking in terms of closure. We have to think about associativity. We have to think about identity element. And my handwriting is letting me down again. So the identity. And we have to think about inverses. Now, it turns out that since I don't have the Klien table in front of me, we want to be thinking about the easiest things first. And so I'm going to go ahead and start that in the following way. We stuck the group identity in K4, and because of that, we know that the group identity is inside K4, and it's going to act as a group identity for K4 as well. So E will be an identity element for K4 since E is an identity element in D4, and K4 is a subset of D4. And I want to think about what the elements up here are. These elements all are known to be their own inverse. So I want to make a note. If I do a 180 rotation followed by another 180 rotation, I've rotated 360 degrees, which means I haven't done anything, so that is E. And if I do a horizontal flip followed by a horizontal flip, that undoes the horizontal flip, so that is E. And finally, if I do a vertical flip followed by a vertical flip, that also winds up giving me back the identity. And so I know that I have inverses. This stuff says that each of the elements inside K4 has an inverse. I guess I should have that E composed with itself is also E. So every element has an inverse. So that's not going to be a problem. And I want to think a little bit about associativity as well. And it turns out that associativity is not an issue. Since D4 under composition is associative, K4 under composition must be associative. If the associativity was messed up in K4, then it would be messed up in D4. It's that simple. There's also another way of justifying it, and I want to kind of point that out as well. There is a big theorem that you were introduced to in your techniques of proof class that says function composition is always associative. So function composition is always associative. So any algebraic structure where the group operation is function composition is known to have the associative property. So this one also holds. So the only thing that we have to worry then about is closure. If K4 is closed under composition, then K4 is going to be a group because we've already seen that the other three axioms are all satisfied. Now, closure is something that we can get by constructing a Cayley table. And that's what I want to do next, is I want to take the time to construct a Cayley table. And let's see, I'm going to have, well, actually, let me write the elements down first. I'm going to have across the top E rotate 180, the horizontal flip and the vertical flip. And here we're going to have E rotate 180, horizontal flip, vertical flip. And now I'm going to put in some lines. And these lines are going to actually have silly little arrows on them because I've been using them for my real analysis class as well, but that doesn't matter. And let's just kind of make that to make the table a little bit pretty. Now, I want to start by filling in the stuff that I already know. And I do want to point out that it is first do the thing in the column and then do the thing on the row. So if I look at something like this particular thing and I write it as H followed by R180, we have to read this backwards. This is actually first do R180, then do H. And that's a really important thing to understand. And what I'm going to do is I'm going to erase that lovely little thing because I don't know what that is right off the top of my head at this point, and we will be finding that out. I want to start with the things that I actually already know. If I compose anything with the identity, I'm going to get the other things. So that means this column is R180, H, and V, and this row is E, R180, H, and V. And we've already seen that if you compose R180 with itself, you get E. If you compose H with itself, you get E. And if you compose V with itself, you get E. So what we have now are 6 more cases that we have to look at. And the easiest way of doing it is literally to brute force it, since we don't have the Cayley table. So I'm going to be drawing a bunch of little squares, and they're not going to look very well, but they will do for what we need to do. I'm going to start with filling in these 2 things. So in other words, I'm going to be looking at first do R180 and then do H. That's this one right here. Now, my standard labeling for a square looks like this. And if I do R180, I get A is down here, B is here, C is here, and D is here. And if I then flip like that over the horizontal line and do a horizontal flip, the resulting square that I get has a B up here and an A up there and a C down here and a D here. And if I want to go from here to here, that is nothing more than a vertical flip. So I'm going to be putting in a V in that particular spot. If I do R180 followed by V, the picture is going to look like this. Here's A, here's B, here's C, here's D. We do R180, we get A, B, C, D, but this time we're flipping over the vertical line. When we do the vertical flip, our square is going to look like DC up on top and AB down here on bottom. And if I want to go from here to here, that's the horizontal flip, so that puts that in. Now, because I want to keep the table with me, I'm going to erase this mess and do the next 2 in the same particular blackboard space that I did these in. So stop the video if you need to copy those pictures down, and after you've got them copied down, start the video back up. So here I'm going to be, oops, let's do a big eraser. Let's get rid of all of the stuff that I need to get rid of because I don't want to have to keep scrolling back and forth on pages. Okay, so for these two blocks here and here, I'm going to be looking at first do H, and then let's see, then do R180. So I start with my square in the standard position, and I'm going to do H, and when I do H, I'm going to have D, A, and C, B. And now when I do R180, let's see, D winds up here, B winds up here, C winds up there, and A winds up here. And if I start looking at going from here to here, what I want to notice is that all I did was a vertical flip. So H followed by R180 is a vertical flip. If I want to do the horizontal flip followed by the vertical flip, I'm going to start with the square A, B, C, D. We do our horizontal flip. And when we do the horizontal flip, we are going to have DA and CB like that. We're now going to do a vertical flip, and when we do the vertical flip, our labels on our square will be CD and BA. And if I want to go from the first position to the last position, what I've done is I have rotated by 180 degrees. So this box here gets R180 put in it. Here again, what you should do is stop the video and copy all those figures down if you need to, and then start the video back up for the computation of these last two cells. So let me go ahead and get them erased. In these last two cells, what I've got to do is I have to be doing V followed by H, and rather V followed by R180 and V followed by H. So if I start off with V and I then do R180, I start with my standard square. I do the vertical flip first, and that will be BACD. And then I do R180. And when I do R180, A is going to land here, C is going to land there, D is going to land here, and B is going to land there, because I am now rotating 180 degrees. So this element here lands here, this element here lands here, this element here lands here, and this element here lands there. Now, if I want to think about what did I do to go directly from here to this picture, notice that that is really nothing more than a horizontal flip. So this is a horizontal flip. So V followed by R180 is a horizontal flip. Our last thing for this little Cayley table is going to be V followed by H. So we start with A, B, C, D. We do V, and when we do V, we have B, A up there, and we have C, D down here because we flipped over a vertical line. Now we're going to flip over the horizontal line. And when we flip over the horizontal line, we're going to have CB on that side, and we're going to have DA on this side. And if I want to start here and I want to go to there, what I notice is that, gee, the A went 180 degrees, the B went 180 degrees, the C went 100. This is R180. So this is R180. Again, I want to stop the video, get all these pictures copied down because I need the space, so I'm going to be erasing them. So let's now get all of this stuff dealt with. And what I want to do next is I want to basically look at my table. The table itself shows that my Klien 4 group under composition is closed. We never got outside of this set by doing composition. And that's enough to say that this particular group is a small group living inside the bigger group of D4, and they use the same operation, so the Klien 4 group is indeed a subgroup of the dihedral group. And that ends this part of the lecture. We will have a third video for the final part of today's lecture.